All right, so we're going to take a look at a confidence interval problem looking with a sample proportion. So here's the problem here. We have a fast food restaurant. The manager is concerned that people are ordering a water cup but then filling it up with soda. Who would do such a thing? So the manager takes a random sample of 80 customers who ask for water, and he finds out that 23 of those customers put soda in their water cup. Okay, so our question here is to construct and interpret a 95% confidence interval for the proportion of all customers who, having asked for water when placing an order, will fill up the soft drink. So we can see what our sample proportion is. So the true proportion is unknown, right? The true proportion, that's the proportion of all customers that order water but then steal soda. We don't know what that is, but we do have a sample proportion. So instead of just calling this P, which is the true proportion, we call it P hat, which means it's a predictive proportion. So our our sample proportion is 23 out of 80, or as a decimal, we can get 0.2875. Okay, so that's the first bit we want to pull out. That's sample statistic. We also know the sample N equals 80. The sample size is 80 customers. Cool, so we'll need these two numbers when we get to the calculations in a little bit. The other thing we need is to know our critical score. So we'll talk about that a little bit when we get there. But we know we have a 95% confidence level, so that'll determine our critical score. Okay, so it's telling us to make a confidence interval. We can't actually start doing the math yet because we haven't proven our three conditions. So anytime we're looking at a confidence interval, we want to take a look at three conditions. The first one is that we need a random sample. And they tell us the manager selected a random sample. So we're just going to trust he did a good job and didn't introduce any bias in his sampling. So we're just going to say the manager took a random sample. All right. The next condition we're going to check is for independence. So in a second, we're going to calculate the standard deviation of the sampling distribution, which the formula assumes that we're working with independent observations. So do we have independence in this situation? It says that we're taking a random sample of 80 people. And in this situation, we don't have true independence. We're not sampling with replacement. So that's not exactly true. But if we don't have independence, we can get away with it using the 10% condition. The 10% condition says that if our sample size is 10% or less of the population, the whole population, then we don't really care about independence because the difference in the calculations are just going to be so small that we don't care. So we're going to assume that 80 is nowhere near 10% of all customers coming in, right? So we're going to assume we've met the 10% condition. I'm going to go ahead and say that, assuming there are more than 800 customers who order water cup. Okay. And the last condition we're going to check here, which is really important, is our large counts condition. So when we take a sample, the sampling distribution for p-hats will be normal as long as we have a pretty big sample. So this is called the large counts condition. It's a slightly different rule when we talk about means, but since we're talking about p-hats, we check the large counts condition. So again, this tells us that as long as we have a big enough sample size, and that also depends on our proportion, then we are going to have normal sampling distributions, which means we can use some normal calculations, which we'll do in a minute. Okay, so the way this works, we do NP is greater than 10. And we don't actually know P, so we're going to use P hat in its place. And we also want to check the complement of P, so 1 minus P hat. Make sure that's bigger than 10 as well. I think we're going to be fine. We got 80 in our sample, but we should just double check. So definitely had 23 out of 80, so that's this. I already know what the answer is, but I'm going to go ahead and write it down just to show my work. So 23 is more than 10. And on the other side, this is going to be much higher than 10. We've got the remaining 57. Right. Cool. So large counts condition is met, so we have a normal sampling distribution. Independence is met, so we're going to be able to calculate the standard error. And we have randomness, which means that this sample is going to be representative of the population. So whatever we find about the sample, we can use that to understand the population. So all three of these conditions should be checked before you start a confidence interval. And actually, you can get away with not doing this one, but we'll talk about that in a second. Just rule of thumb, always do all three. Oakley doodle. So now we need to actually calculate our confidence interval. So if you look at your formula chart, you'll see something like this. A confidence interval is the statistic plus or minus the critical value times the standard error of the statistic. Sorry, I'm getting off my pad here. So you'll see something like this on your formula chart. So we're going to go ahead and, don't want to look at that yet. Go ahead and fill this out. So our statistic, our sample statistic, in this case, we're using p hat. So we want the p hat. And then our critical value, we're going to be using z here. We're doing a one sample z interval. So this is pretty much a z-score, but instead of measuring how many standard deviations away we are, we're going to be looking at how many standard errors we are. So don't call it a z-score, although it's kind of the same thing. And then our standard error, this formula is also on your formula chart. The square root of p hat times 1 minus p hat all over n. And you want to be careful with your symbols here. Don't say p when you mean p hat, because we don't know p. So if you plug in this value for p, you're lying because we don't actually know what p is. Okay, so we're going to plug in all of our values, except I'm not going to do this. I don't want to do all the math, and I've done a good job of identifying the formula of what I need to do. So I'm actually going to use my calculator to do this last part because it's less work, and I've shown enough that I know what I'm doing. I know what to plug in things in. I've identified what p hat is, and I show that I'm going to put p hat here and all that stuff. I haven't said what my critical value is yet, so I might want to mention that. For 95% confidence, z is going to be 1.96, and this is the most common confidence interval, so we might have that value memorized. If not, we can talk about how to do that in a different video. Okay, so I'm actually going to have my calculator do this. If I go to click the stat button here, go over to tests, and scroll down, I'll find a 1 proportion z test. Oops, I passed it. No, I didn't. That's not what I want. I want this one. 1 proportion z interval, sorry, because we're doing a confidence interval. So you'll see this menu. If you have the older software, you'll just have to fill these numbers in. But here's what we got. We got 23x, so that's number of successes. So we had 23 soda stealers out of our total 80. And we want to do a 95% confidence level. Notice the percent as a decimal in the calculator. And we get our answer here. So this looks like a good answer, from about 18.8% to about 38.7%. So we should have a confidence interval that surrounds our p hat, and 0.28 is right in the middle of 18 and 38. So this is looking pretty good. So I've got my confidence interval calculated. Notice I didn't actually do the math. I used the calculator, and that's totally fine as long as you include something like this formula, something to make sure you've identified what you're doing. The formula is a great way to do it. You could also name it. If I just wrote down this, I'd be okay. 1 proportion z interval. But you have to prove that you know what you're doing. You can't just produce an answer without any explanation. Okay, and we'll talk about the scoring in just a minute. As you can see over there, we'll get to it. So I've constructed my confidence interval, but I haven't interpreted it. So I'm going to do that next. So what does this mean? This means we are 95% confident confident, sorry, my pen's freaking out, that the true proportion of water cup soda thieves is captured by the interval from 0.188 to 0.387. So we're 95% confident that the true proportion of people that are stealing soda with their water cups is somewhere between about 19 and 39%. So you want to be kind of careful when you're writing your interpretive sentence here, you're talking about your confidence interval. It can be really tempting to say there's a 95% chance that our values in there, but that's not technically correct. It just means that if we constructed this confidence interval over and over and over again with a sample of this size, with a true p of whatever p is, we'd capture the true proportion 95% of the time. So this is a nice way to say it. I would just kind of stick to this sentence. We're not going to do part B, but it's kind of interesting, so I'll look at it really quick. It says he wants to know how much money is being stolen from him, basically. So he says each water cup stealer costs the restaurant 25 cents. It says in June there are 3,000 customers who asked for water. So you can use the confidence interval to give an estimate of how much money was lost. So I think we could do that pretty easily. We've got 3,000 customers, and somewhere between 18.8% of them and 38.7% of them, so we can find those values. What is 18.8% of 3,000, right? And the top number as well. Find those numbers and then multiply it by 25 cents, since each one of those people is stealing 25 cents. So I'm not going to do part B, but I am going to talk about the scoring, because I think it's really important when you're studying for the AP test to know where you can lose points. So you can either score a essentially correct, a partially correct, or incorrect. So here's what you have to do. If the one sample z interval for proportion is identified, and notice it says either by name or formula, okay? So I wrote down the formula, which is ideal to show that you know how to do the math, even if you don't actually do it, even if you use the calculator. I know what I would do. And then you can also name it as well. And it says both conditions. So we actually did 3 conditions, but it says you had to say something about random sampling and a large enough sample. Okay, so those 2 things have to be talked about to get your full points. We did that. We said it's a random sample, so that means our sample is representative of the population. And maybe I should have written that as well, but I think this is okay. And I checked my large counts condition, saying that our sample's big enough that we'll have a normal sampling distribution. We also checked for independence, and that's not a bad thing that we did that. You'll see in the notes here it says something about stating and checking condition, I thought it said something about this. Oh, here it is. Stating and checking a condition about the size of the sample relative to the size of the population is appropriate, but not required. So for this question, they didn't take points if you didn't say anything about independence or 10% condition, but it's not wrong, right? It's appropriate. There's some interesting stuff in here, though. Some places where people commonly miss points. The next video will be a confidence interval for sample means, and it's a similar process to calculate that. You'll see that in the next video, but we don't do the large counts condition when we look at x bars instead of p hats. When we look at x bars, we have a different check for a big enough sample, and it's n is greater than 30 to make sure we have a normal sampling distribution. So if you say something about that, that's automatic missing points. Or if you're doing a sample mean and you say something about the large counts condition, automatically lose points. So it's really important that we keep those distinct. And we'll see an example of that. Yeah. notice that here's a note saying that just saying that we have a big enough sample is not sufficient. You actually have to do this quick little calculation. And you might feel like that's not really necessary, but if you don't show that you've actually plugged this in and made sure that your sample's big enough, mathematically, you can lose those points. All right, cool. So that's a one sample Z interval for proportion. The next video we'll look at same thing, but with sample means instead of proportion.